Dear children, today's topic is electrophilic substitution reaction in benzene. And here we are going to discuss chlorination of benzene. We know benzene undergo electrophilic substitution than addition, polymerization or nucleophilic substitution reaction because we know benzene is highly electron rich and it has an electron cloud. So electrophile means electron loving agents will be attacking the benzene ring than the nucleophilic reagents. Therefore, benzene undergo electrophilic substitution faster than nucleophilic substitution, but rarely that undergo nucleophilic substitution, but the mechanism is different. Also, benzene will not undergo addition reactions, oxidation, polymerization, etc. This is because on addition reaction, the new aromaticity of benzene ring will be lost. Same like benzene will not undergo oxidation with KMnO4 also, and polymerization reaction also benzene will not take part. That means polymerization because of resonance in benzene, the polymerized products will be destroyed. So benzene will undergo electrophilic substitution regularly, and for sometimes it will undergo nucleophilic substitution reaction also. So in this class we are going to discuss chlorination of benzene. Now we will discuss electrophilic substitution reaction. It's an introduction. Reaction initiated by substances which are either electrophile, that means electron loving or electron deficient, or which generate some electrophile by reaction with some other reagent. Then the electrophile attacks the benzene ring. Substitution of electrophile takes place by replacing one of the hydrogen atom of benzene ring, and electrophilic substitution, benzene retains its aromaticity. Here I have given one example. Benzene undergo addition and substitution with addition with 2E plus and substitution with E plus. So when addition undergoes this, that substituents will be attached to this carbon atom. So this double bond will be converted into single bond. So in the addition products, the benzene loses its aromaticity, while during substitution, one of the hydrogen atom of benzene will be replaced with the electrophile. So benzene retains its aromaticity during electrophilic substitution reaction. So this is the general mechanism of electrophilic substitution reaction. Actually the reaction takes place in 3 steps. Step 1 is the generation of electrophile. So this is our reagent. First step is generation of electrophile. So this is a reagent for the production of electrophile. That will be having one nucleophilic part and the electrophilic part. So nucleophilic part will be more electronegative. So that will take the electrons from this bond. So that electron will be shifted towards the nucleophile. So that will be formed as E plus and Nu minus. So this one is the electrophile. So first step is the generation of electrophile, and step 2 is the formation of carbocation intermediate. This electrophile will attack to this benzene ring and that will form carbocation intermediate. And step 3 is abstraction of proton from the carbocation intermediate by this nucleophile, and it will form the substituted product. Now we will discuss halogenation of benzene. Benzene on treatment with chlorine or bromine in presence of halogen carriers like FeCl3, AlCl3, zinc chloride, BF3, etc. And in the absence of sunlight, it will form nuclear substituted products. An example is benzene plus Cl2. In presence of this catalyst FeCl3, it will form chlorobenzene. This FeCl3 is used for the polarization of this Cl2. Usually the loosely held pi electron of the double bond in alkenes polarize the halogen molecule even in the absence of Lewis acid catalyst. Instead of benzene, if it is any alkene, there is no need of FeCl3. But in the case of benzene, the pi electron cloud in benzene is relatively less available, and consequently the presence of Lewis acid catalyst is necessary to polarize this halogen molecule, because these are the electron cloud in benzene is relatively less available. That is why here FeCl3 is used for the polarization of the Cl2 bond, because we cannot use a pi electron of this benzene molecule for this polarization of Cl2 molecule. That is why we are using FeCl3 as a catalyst during halogenation. Now let us discuss the mechanism. Step 1 is generation of electrophile. Here Cl plus ion is the electrophile for the chlorination of benzene. So here Cl2 molecule will be polarized in presence of FeCl3 catalyst. It will form Cl plus and FeCl4 minus ion. Here Cl bond will be polarized. So one Cl will act as the electrophile and the other Cl will act as the nucleophile. So if this chlorine is the nucleophile, then this bond electrons will be shifted towards this chlorine atom. So if this chlorine is the electrophile, that electrophile will loses the electron to this nucleophile. So it will form Cl plus and Cl minus. This Cl minus will react with this FeCl3. It will form FeCl4 minus. So this Cl plus is the electrophile during chlorination of benzene. Step 2 is formation of carbocation intermediate. This is the rate determining step or the slow step. Here the electrophile, our Cl plus ion, chloronium ion, attacks the benzene ring, leading to the formation of resonance stabilized intermediate carbocation. So here this is the benzene ring, this is the Cl plus. So this Cl plus will be attached to this benzene ring using that electron cloud. So here this one electron, this pi electrons will be shifted towards this carbon atom. So here this electron will be shifted towards this carbon atom. So this carbon atom will be having negative charge and this carbon atom will be having positive charge. So this electrophile will be attached to the electron rich center of the carbon atom. So this electrophile will be attached to this carbon. So what will be the product form? So what about that carbon? The carbon which loses the electron. This carbon will be having positive and this carbon will be having negative charge. So this Cl plus will be attached to this chlorine. So it will form here positive and here chlorine atom. We know carbon having total 4, valency is 4. So 1 will be the hydrogen atom. Then in the next step, here this one is positive. So this double bond, this pi electron will be shifting towards this carbon atom. So here electron will be shifted towards this carbon. So what will happen? This carbon will be having positive charge and this carbon will be having negative charge. So that negative and positive ions together, that will form a double bond here and this will be positive. So in the next step, this electron cloud will be shifted towards this carbon. So this carbon will be negative, this negative and positive, it will be a double bond and this carbon atom will get positive charge. That is written here. So this can be written as a resonance hybrid because this is a carbocation form and here we can draw a half circle only because electron, the benzene ring is not having its sextet complete. Only 2 pi bonds are here. That is why we didn't draw a complete circle because it is a resonance hybrid of these canonical forms. Step 3 is abstraction of proton by the nucleophile. So from step 2 we got a resonance hybrid structure or the carbocation intermediate. That carbocation intermediate loses the proton and that will form a substituted product. So the nucleophile from the step 1 will abstract this proton and the substituted products will be formed. So the nucleophile from step 1 abstracts the proton from the intermediate carbocation and the loss of proton allows the electrons from CH bond, this CH bond, to go back to the ring, restoring its aromatic system. So here this HCl and this positive ion is there. So this H has to be removed from here. So this H will lose as H plus ion and that will give this CH bond will be broken and that electron will be given back to the ring. So that electron and this positive charge here, one double bond will be formed. So dear children, today we have discussed electrophilic substitution reaction in benzene, and today's class we have discussed chlorination of benzene. Hope the mechanism is clear. Thank you for watching. Please like, comment and subscribe for more videos.